Hello and what's up, amazing people. Welcome to the next video in this series of stoichiometry, where we've been looking at the topic. We've introduced it in our previous video and we're moving on to talk about the place of chemical equations in stoichiometry. So let's get into what we have for today's video. So first things first, before students can become good at chemistry calculations, you must learn how to read chemical equations properly. You see, becoming good at chemistry calculations is like climbing a set of stairs. You need to take it one step at a time. So we've taken the introduction. Now we want to look at chemical equations and how to read them like a sentence before we move into the concepts of calculations. You see how we're taking it one step at a time, and very soon you're going to be at the top where you know how to read stoichiometry like the back of your palm. So, like I said, students must become good at chemistry calculations. They first need to learn how to read chemical equations properly. And how can that be done? Well, let's talk about some parts of a chemical equation. We have the first part, which states or which talks about the reactants and the products. Every chemical reaction has two main sides. Side number one, the reactant. Reactants are the substances that you begin or start the reaction with. Now think of reactants as ingredients. Before you produce a particular meal or a particular dish, you have to start with the ingredients that you combine together. Those ingredients that you use in chemistry, they are called the reactants. So here's a good example on the screen right now. We have wood combining with oxygen. When these two combine together, they form ash, smoke, and heat. Now, if the question is posed to you saying, what are the reactants in this chemical equation? Definitely, it will be the wood and it will be the oxygen, because they are the substances that you started with. They are the substances that you started or began with. Can you see how this is playing out? So reactants basically are the substances that you begin with. So we have the next one, which is products. Products are the substances that are formed after a chemical reaction has taken place or happened. They are simply the final result. Using our example again, wood combined with oxygen to produce ash, smoke, and heat. If I ask you what the products are, it would simply be the final result, which is the heat, the ash, and the smoke. These on the right hand side of the equation are the products. I trust you're getting massive value for today's video. If you are, consider liking, sharing, and subscribing to this YouTube channel. So let's check out some examples and see how we can read or identify reactants and products in a chemical equation. Equation number one, we have magnesium Mg reacting with oxygen O2 to produce magnesium oxide MgO. What are the reactants and what are the products in this equation? Well, the reactants are simply the substances that we began the chemical reaction with. So you can see the substances on the left hand side of the equation. These, my friends, are the reactants. The reactants are magnesium Mg and oxygen O2. The product is on the right hand side of the equation, magnesium oxide MgO. We've identified the products, we've identified the reactants as well. So now that we've seen how to identify products and reactants, it is also important to move on to the next part of a chemical equation, which is the coefficient. Now the coefficient in a chemical equation is simply the big number that's written in front of a chemical formula. So for instance, we have this equation on the screen, this equation that depicts the formation of water through the reaction of hydrogen and oxygen. Now, if you watch very closely, you would see that there are some numbers standing in front of the formulas of elements and compounds. So for hydrogen, we have H2. There is a big number 2 standing in front. That 2 is the coefficient of hydrogen. If you see oxygen, there is no number standing in front, but automatically we know that there is a number 1, because anything standing alone is by itself and is a number 1. Now we have water H2O standing with a number 2 in front. This number 2 is the coefficient of water H2O because there's a 2 standing in front of it. Now, what is the significance of coefficients? Coefficients simply tell us how much of each substance is involved in the reaction. So for this equation on the screen, if I'm to read it like a sentence, it would simply sound like this. 2 parts of hydrogen, because I have 2H2, reacts with 1 part of oxygen, O2. There is an imaginary number 1 here, to produce 2 parts of water, H2O. Easy, simple, and basically straight to the point. I have depicted and I have read this chemical equation as though it were an English sentence. So that word parts is very important. You'd notice that when I was talking about the coefficient, I was saying 2 parts of hydrogen reacts with 2 parts of water. So that word parts is very important. That part can be referring to molecules, it can also be referring to number of moles, and it can also be referring to particles. We will talk about each and every one of these ones individually. So when that will come in when we focus on moles later. I just want you to enjoy this part of the series as we move on step by step. I trust you're getting value. So let's come to the part of reading chemical equations like sentences. So equations can actually be read like normal sentences. We talked about the example of this one where we said 2 parts of hydrogen reacts with 1 part of oxygen to produce 2 parts of water. Let's see if we can read some other ones as examples. So we have this equation on the screen. N2. There is no number standing in front. Okay, that automatically means there's an imaginary number 1 here. So let's read it as 1 part of nitrogen, and then we have plus 3H2 reacts with 3 parts of hydrogen, and then we have this arrow 2NH3 to produce 2 parts of ammonia, because basically NH3 means ammonia. So I've read and depicted the chemical equation like an English sentence. So can you see how all of these things are playing out? Now that you understand the basics of reading chemical equations like sentences, you're fit to move into the next part of this series where we'll be talking about the mole ratios. I trust you're getting massive value. If you are, consider liking this video, sharing, subscribing to this YouTube channel so we can reach more students and do more good in the educational space. Up until the next video, my name is David, a high school chemistry tutor for kids, and I trust you're getting value. Up until then, stay safe and God bless.